Hello and welcome to Excellent Link Academy. For today, we're considering system of forces, right? System of forces. What's the concept behind system of forces? When it comes to system of forces, it's simply a technique of knowing all the forces acting on a system. That's like the concept behind system of forces. When it comes to system of forces, we'll be considering two things there, right? We're considering static forces and dynamic forces, right? We're considering two things here. The first one there is called the forces, and the second one there is called forces. So the first one there is called static forces, and the other is called dynamic forces. But for today, we're considering the first one called static forces, right? Statics and dynamics, right? Actually, static is not actually okay. Let me relate them with first. Most cases we relate static and dynamic in terms of motion, right? But let me just relate them with first to understand the concept well, right? All right, let's call system of forces. Let's start with the first one called static force, right? Static force, right? Static forces, right? Let's discuss the first one called static forces. What are static forces? A static force is simply a force that acts on a rigid body. That's all. So any force that acts on a rigid body is said to be static forces. Static force per se, static force, right? So any force acting on a rigid body is said to be what? Static force, right? Now, when it comes to static force, there are some things you need to note, right? Um, first things first, when it comes to static force, I will have something of this nature. The graph of static force looks something like this. I have this in this case here. This is plus, minus, plus, and minus. We call this what? X axis here. We call this Y axis. X axis. We call this Y axis, right? So when it comes to static force, note that um any this is look at this in a graph sense. When it comes to a graph, I'll have my X axis and Y axis. So when it comes to static, the upward force is positive, downward force is negative, right force is positive, and left force is negative, right? So note the following. Note the following. Note the following. Number one. Note the following. Number one. Any force acting parallel to the horizontal axis. Any force acting parallel to the horizontal axis is called f of x. Is called f of x, or summation of horizontal component. I said, note number one, any force acting along x-axis is called f of x, or summation of horizontal component, where f of x means force acting along x-axis, and summation of h means summation, or perhaps the addition, summation of horizontal component. All right, horizontal components. That's like the definition of the parameter f of x and summation of h. So f of x means force acting along x-axis. Summation of h means summation of, or perhaps addition of horizontal components. So that's like the idea. So the diagram for expressing this is something of this nature. If I have this and I have this, let's say this is a force here, this force here, this is this force 1 and this is force 2. Look up, I said note number 1 is that when a force is acting along x-axis, this x-axis, either facing right or facing left. Look at it. Oh, this is positive, this is negative side. This will give, when it's facing right, it gives the positive side. When it's facing left, it gives what? Negative side. So any force acting in this sense, we call it what? F of x, or summation of horizontal component, right? Note number 2, note number 1, note number 2, note number 2, note number 2, any force acting along y-axis is called f of y, or summation of v, that is summation of vertical components, where f of y means forces acting along y axis, and we call this one the summation of vertical component. That's like the concept behind this one here. That is, any forces acting vertically. So the diagram to express this one is that if I have a force acting up or downward this way, I will call, let's say this F1 and this is F2. So far this is going upward is positive, this going downward is what? Negative. From this concept, negative, positive. Yeah, for this one here, I have positive, negative. So this is vertical sense, right? So when a body is moving vertically, right, so it is called what? The f of y, or summation of v, that is summation of horizontal vertical components. And these are the concept behind system of forces, right, for static forces here, right? Now let me just show you the difference between static forces and dynamic forces. Static forces, I've shown this for static forces. Static forces agree with the phase that says that right force is x, left is negative, upward is positive, downward is negative. For dynamic, upward, observe, upward is negative, down is positive, right is positive, left is negative. This is for dynamics. Yeah, dynamics. But we won't discuss this one here much more later. Let's dive into static forces first. All right, at this point here, let's now further explain all this concept here. Right, let's discuss case 1, case 2, case 3, and case 4. Right, this stuff as case 4, right? Case 1 to case 4. Let's start with case 1. Yeah, case 1, let's consider something. Case 1 says, let's start with the force acting along x-axis. Case 1, force acting along what the x-axis. To consider the force acting along x-axis, note the following, please. Let's say an example. Let's say I have an object this way. This object is pulled to the right with a force F1, call it 3 Newton, and there's a force pulling this object backward. Let me call it F2 to be what? 2 Newton. So in this case here, I'm taught to find the net force, right? So my net force here, F of net is equal to F1 plus F2. That formula. So now from here now, my net force F net is equal to F1. What's F1? F1 is 3 Newton. Now observe that this is 3 Newton. I agree it's 3 Newton. But what is facing what? A right direction. And we said Right direction is what? Positive. So it's already what? A positive 3. That becomes 3 plus, this is F2. F2 is 2 Newton and facing what? The left direction. Any forces facing left direction is said to be what? Negative. So I'll have what? The a negative 2 Newton. Simplify this one better, I'll have that my net force is equal to 3 plus, negative 2 Newton, please. Negative. Plus minus is minus, and I have 2 here. Of course, my net force, which is the same thing as my f of x, is now equal to 3 minus 2 is what? Is 1 Newton. These are like this, like the case 1 here, right? To find the sum of the forces here acting along the s-axis. So I can call this f net or call it f of x, right? It's still the same thing, please, right? I can call this f of x, right? I can say my f of x now is equal to 1 Newton. So same thing, please. This is like the force acting along s-axis. So right, we're considering f of x. So I can still call this f of x to be equal to f1, f2, right? It's like the condition here. Let's say I have an object this way, and this object is a force pulling this object. Let's call it F1 to be 3 Newton, and also that same force is pulling it in this direction. Let's call it F2 to be 4 Newton in this case here. My question now is to find the net force, or find the f of x, the force acting along s-axis here. So let me just say I can use f net, or what? F of x to be equal to f1 plus f2. From here now, my f1 is 3 Newton. Observe the direction, right hand side. Right is positive, so I have 3 plus 3 there. Next up plus, this is a f2, and f2 is 4 Newton. Of course, facing what? My positive direction, that becomes 4. If I find my f of x, that is force acting along s-axis on this figure here, is equal to what? 7 Newton. This is like the condition behind case 1. Understand the condition here. For case 2 there, for my case 2, let's consider the force acting along y-axis. We just consider force acting along x-axis. Let's now consider force acting along, what's there? Y-axis. Right? Let's consider the forces acting along y-axis. That's f of y. F of y. Right? Now, when it comes to considering force acting along y-axis, note that, look up, please. Look up. Let's use an example to illustrate this. Example 1. Let's say I have an object this way, and I have a force going up and coming down this way, pulling this object. Let's call this F1 to be 3 Newton. Let's call this F2 to be what? 4 Newton. Right? So to get my what's it called here? To get my F net here, or perhaps f of y, I can call it F net or f of y. So my f of y is equal to f1 plus f2. The same formula with f of x, right? The same thing, right? The same formula. So to find my f of y, so let's get f of y. My f of y is equal to f1. What's f1? This is 3. I have 3. Why is it plus 3? Upward force is said to be what? Positive. We just said that here, that any force going up is what? Positive. So I have plus 3. Next one, this is plus f2. F2 is coming downward, and downward force is what? Negative. So I'll have minus 4. Simplify this one better. My f of y is equal to 3. Plus minus is minus, then 4. My f of y is equal to negative 1 Newton as my value after finding the summation, or perhaps the force acting along y-axis. Next class, we'll consider the case 3 and case 4. For my case 3, that becomes when the forces are not even acting along x and y. What of if they are acting perpendicularly? That is, they are acting in this form. Let's say this F1 and this is F2. So what will be their net force if they are acting perpendicularly. That's for case 3. For case 4 there, what if they are acting at an angle, at something of this nature, at an angle, right? What will be the force there? So for when it comes to perpendicularly, well, we use the idea of resultant force, right? That will take us to resultant force. When it comes to at an angle, that will take us to revolution of forces. So next class we'll be considering resultant force and resolution of forces. If you found this class helpful, reach out by liking the video and sharing it to your classmates and friends. Thank you. Welcome to Excellent Link Academy. See you in the next class.